Imagine a civilization so advanced that it completely controlled the most essential element of life: water. A city lost in the sands of time that developed water technologies that would baffle modern engineers. This is not just another urban legend or ancient myth, but an archaeological reality that is revolutionizing our understanding of the capabilities of ancient civilizations. Prepare to discover the secrets of Petra, the pink city that dominated the desert through its absolute control of water. If you're curious about how our ancestors achieved seemingly impossible feats, like, subscribe to the channel, and comment below what time you're watching this video. This helps the channel a lot and shows me when you most enjoy watching this type of content. Located in what we now know as Jordan, Petra emerges from the reddish rocks like a materialized mirage. But this ancient city hides secrets that go far beyond its carved stone facades. For centuries, archaeologists and historians have wondered how a civilization managed to thrive amidst the arid desert, maintaining an estimated population of over 30,000 at the height of its development. That the answer was literally at their feet. The Nabateans, the Arab people who founded Petra around the 4th century BC, not only survived in the desert, they conquered it through hydraulic engineering so sophisticated that it still inspires admiration. Among the world's most renowned experts, when you walk the narrow trails that lead to the heart of Petra, you're exploring much more than just rocky passages. Every crevice, every channel carved into the stone is part of a complex, interconnected system that transformed an inhospitable region into a thriving oasis. The Nabateans understood something fundamental: whoever controls the water, controls life. Petra's water harvesting system began long before the city's visible boundaries. The Nabateans identified and mapped every water source within a radius of tens of kilometers, from small natural springs to points where rainwater temporarily collected. They didn't let a single drop go unnoticed. But capturing water was only the first step. The real genius lay in transportation. Nabatean engineers created a system of aqueducts and canals that snaked through mountains and gorges, following the natural contours of the terrain with impressive mathematical precision. These were not simple holes dug into the rock, but carefully calculated structures that took into account topography, water pressure, and the need for constant maintenance. Petra's aqueducts have unique characteristics that demonstrate a profound understanding of hydraulics. The interior walls were lined with a special mortar that prevented leaks and algae growth. The slope was calculated with millimeter precision to ensure the water flowed at the ideal speed, neither too fast to prevent erosion nor too slow to prevent stagnation. But perhaps the most impressive innovation was the reservoirs. The Nabateans carved enormous cisterns into the solid rock, some holding thousands of liters of water. These underground structures were veritable aquatic cathedrals, with natural filtration systems that kept the water clean and drinkable for long periods. What makes these reservoirs even more remarkable is how they were integrated into the city's architecture. Many of Petra's temples and important buildings were built directly over cisterns, creating a perfect symbiosis of function and form. Water was not just a practical necessity. It was an integral part of the Nabateans' cultural and religious identity. The complexity of Petra's water system becomes even more evident when we analyze the internal distribution channels. Water collected from the main reservoirs was distributed throughout the city through an intricate network of smaller canals, supplying everything from private residences to public baths and gardens. Each neighborhood, each important house had its own access to the central system. Archaeologists have discovered that the Nabateans also developed an extremely sophisticated flow control system. Stone floodgates regulated the amount of water reaching different sectors of the city, ensuring equitable distribution even during periods of scarcity. It was a true water democracy, where access to water was carefully managed to benefit the entire community. During the rainy seasons, which were brief but intense in the region, Petra transformed into a gigantic water harvesting machine. Every roof, every rocky surface was designed to channel rainwater into the storage system. The Nabateans literally sculpted the landscape to maximize water capture, creating a perfect harmony between human architecture and natural geography. But Petra's control of water went far beyond basic survival needs. The Nabateans understood that water could be a tool of political and economic power. Petra was strategically located on the trade routes connecting Arabia, Africa, and the Mediterranean. Caravans laden with spices, incense, and silk had to cross hundreds of miles of desert, and Petra offered something no other city in the region could guarantee: abundant and safe water. Merchants paid high fees not only for the right to trade in the city, but also for the privilege of replenishing their water supplies. Before continuing their journeys, Petra became indispensable, a must-see oasis that generated immense wealth for its inhabitants. Water was literally converted into gold. This prosperity allowed the Nabateans to invest even more in their water infrastructure. They developed purification techniques that ensured the water remained drinkable even after long periods of storage. Natural aeration systems prevented the water from becoming stagnant, while sand and charcoal filters removed impurities and unwanted flavors. The importance of water in Nabatean culture was also reflected in their religious rituals and social practices. Public baths were centers of community life, where business deals were made and political alliances were forged. Water was not just a material resource. It was a sacred element that connected the community and legitimized the power of rulers. The gardens of Petra are another testament to the Nabatean mastery of water. Amidst the arid desert, they managed to create veritable green paradises, with ornamental plants and fruit trees that required constant and careful irrigation. These gardens were not just displays of wealth, they were declarations of power over the natural elements. Recent research has revealed that Petra's water system was even more extensive than previously thought. Using radar and satellite mapping technologies, archaeologists have discovered tunnels and canals extending for miles beyond the city's known limits. Petra wasn't just a city that controlled water, it was the hub of a veritable regional water network. These discoveries suggest that the Nabateans not only collected and stored water, but also exported it to neighboring communities. They created the first known regional-scale water distribution system, establishing Petra as the water capital of an area covering thousands of square kilometers. Nabatean technology also included innovations that would not be rediscovered in Europe. For many centuries, they developed pressure valves that automatically regulated water flow in different parts of the system, siphon systems that allowed water to rise to considerable heights, and even rudiments of pumping systems that harnessed the natural energy of the moving water itself. One of the most fascinating discoveries was a complex of laboratories where the Nabateans apparently tested different materials and construction techniques. Mortar fragments with varying compositions suggest they were constantly experimenting to find the best solutions for waterproofing and durability. It was a true applied science of hydraulic engineering. Petra's decline paradoxically began with changes in maritime trade routes that reduced the importance of land caravans. As trade shifted to Mediterranean ports, Petra lost its main source of revenue. Without the resources generated by trade, it became impossible to maintain the complex water infrastructure that sustained the city. Petra's last inhabitants fought to preserve at least parts of the water system, but maintenance required specialized knowledge and resources that were no longer available. Gradually, channels became blocked by sediment, cisterns developed cracks, and the system that had functioned perfectly for centuries began to fail. When the last Nabateans abandoned Petra in the 7th century AD, they took with them technological secrets that had been lost for over 1,000 years. The city was gradually covered by desert sands, and with it, one of the most impressive feats of hydraulic engineering of antiquity. The rediscovery of Petra by Western explorers in the 19th century revealed only a fraction of its wonders. The magnificent rock-cut facades immediately caught attention, but the city's true treasure remained hidden for decades. Only with the advancement of modern archaeological techniques has it been possible to understand the true extent and sophistication of the Nabatean water system. Today, modern engineers study the solutions developed in Petra to address contemporary water management challenges. In a world where water scarcity is becoming a growing concern, Nabatean techniques offer inspiration for the development of sustainable technologies that maximize the use of limited resources. The precision of Nabatean hydraulic calculations is impressive even by today's standards. Modern measurements have confirmed that the gradients of Petra's aqueducts follow mathematical principles that ensure optimal flow with minimal energy waste. They achieved this without modern precision instruments, relying solely on careful observation and empirical knowledge passed down through the generations. A particularly notable aspect of Nabatean engineering was its environmental sustainability. Unlike many ancient civilizations that exhausted their natural resources, the Nabateans developed a system that worked in harmony with the natural water cycles. They collected water during rains, stored it during droughts, and never extracted more than the natural aquifers could replenish. The sustainable approach allowed the system to function for centuries without significant environmental degradation. The Nabateans intuitively understood conservation principles that modern science took decades to formalize. They were true pioneers of sustainable water resource management. The construction techniques used at Petra also reveal advanced knowledge of geology and materials. Engineering. The Nabateans knew precisely which rock types were best suited for different components of the water system. Canals were dug in sandstone, which offered ease of work, while structures that needed to withstand high pressure were built in more resistant limestone. They also developed specific techniques to deal with the thermal expansion and contraction that affects desert structures. Strategically placed expansion joints prevented extreme temperature changes from causing cracks in the stone structures. This was engineering that considered not only immediate function, but also long-term durability. Maintaining the system was a complex operation that required a specialized hierarchy of technicians and administrators. Inscriptions found at Petra mention specific positions such as Guardian of the Waters and Master of the Canals, suggesting that water control was a primary concern of the Nabatean government. Administrative records engraved in stone reveal sophisticated water quality monitoring systems. The Nabateans regularly tested stored water, discarding any reservoirs that showed signs of contamination. They understood the connection between water quality and public health long before this relationship was formally established by modern medicine. The Petra system also included components that were only redeveloped in the industrial era, structures that functioned as decanters separated sediment from the water before storage. Natural aeration systems kept the water oxygenated and fresh. Even rudiments of natural chlorination systems have been identified, utilizing the antibacterial properties of certain rocks and minerals. The integration of the water system with Petra's urban architecture demonstrates a level of planning rarely found in ancient cities. Every street and square was designed with water flow in mind. Drainage systems prevented torrential rains from causing flooding, while ornamental canals created more pleasant microclimates. In public spaces, this integration went beyond the purely functional. Water was incorporated as an aesthetic and symbolic element in Nabatean architecture. Decorative fountains were not merely ornaments, but visible demonstrations of the abundant water that distinguished Petra from other desert cities. It was an architecture that celebrated mastery over the natural elements. The public baths of Petra represent the height of Nabatean water sophistication. These complexes included not only pools of varying temperatures, but also elaborate water heating and circulation systems. Hypocausts, underground heating systems, kept some pools warm even during the cold desert nights. The heating technology used by the Nabateans was surprisingly efficient. They harnessed solar energy during the day to heat large volumes of water, which were then kept warm by natural thermal insulation systems. Specially selected rocks retained heat for hours, providing gradual and constant heating. Recent research has revealed that the Nabateans also experimented with natural cooling systems. Underground structures took advantage of the constant ground temperature to cool water during the hottest summer months. It was a primitive but effective form of air conditioning that kept water reservoirs cool, even in the scorching desert temperatures. Nabatean knowledge of water behavior was extraordinarily detailed. They understood principles of hydrostatic pressure, allowing them to build fountains that spurted water to considerable heights without the need for mechanical pumps. They utilized natural differences in elevation and pressure to create spectacular effects that impressed visitors and demonstrated the city's technological prowess. Recently discovered inscriptions suggest that the Nabateans kept detailed records of regional climate behavior. They documented rainfall patterns, dry periods, and seasonal variations with precision that rivals modern weather stations. This knowledge enabled long-term planning and proactive water resource management. The influence of Nabatean water technology spread far beyond Petra. Communities throughout the region adopted techniques developed in the Pink City, creating a true revolution in water management in the ancient Middle East. Petra was not just a prosperous city, it was a center of technological innovation that transformed an entire region. Archaeological evidence shows that engineers from Petra traveled to other cities, offering advice and overseeing the construction of smaller water systems. They created a veritable network of technical expertise that connected communities separated by hundreds of kilometers of desert. This technological diffusion also had important political implications. Cities that depended on Nabatean expertise naturally became allies of Petra, creating a sphere of influence that went far beyond direct military power. Control of water technology was a subtle but effective form of regional diplomacy. Petra's legacy remains relevant to contemporary water management challenges. In arid regions around the world, engineers study Nabatean solutions to develop appropriate technologies that maximize the use of scarce resources. The ancient desert city offers valuable lessons about sustainability and environmental adaptation. Modern projects in countries like Israel, Australia, and Chile have incorporated principles developed in Petra over 2,000 years ago. Rainwater harvesting systems, underground storage techniques, and efficient distribution methods are direct adaptations of Nabatean innovations. Petra's story reminds us that technological innovation and environmental sustainability are not contradictory concepts. The Nabateans proved that it is possible to thrive even in challenging environments, as long as we develop technologies that work in harmony with natural systems, rather than against them. Today, as we face global challenges of climate change and resource scarcity, Petra offers an inspiring vision of how civilizations can adapt and thrive through smart innovation and responsible stewardship. The lost city that controlled the water continues to teach valuable lessons about human resilience and technological ingenuity. Petra's secrets continue to be unraveled through advanced archaeological research. Each new discovery reveals additional aspects of Nabatean sophistication, confirming that we still have much to learn from this extraordinary civilization that transformed the desert into an oasis through absolute mastery over the most essential element of life. The Pink City stands as an eternal testament to what is possible when knowledge, determination, and respect for nature combine to create truly innovative solutions. Petra wasn't just an ancient city, it was a vision of the future we're still trying to achieve.